Find angle measures in polygons. Our learning targets are to use the polygon angle sum theorem to find the sum of interior angles of a polygon, find the measure of one interior angle in a regular polygon, use the polygon exterior angle sum theorem to figure out the sum of exterior angles of a polygon, find the measure of one exterior angle of a regular polygon, and use algebraic equations to determine missing interior and exterior angles. So first, let's discuss what a diagonal of a polygon is. So a diagonal of a polygon is a segment that joins two non-consecutive vertices. So by non-consecutive, you would say B, skip C, D. So BD is our diagonal. Or we could do B, skip vertex A, go to E, so BE is a diagonal. And notice this diagonal cut my pentagon into 3 triangles. Just pointing that out. So, a polygon interior angle theorem says that the sum of the measures of the interior angles of a convex polygon, so an n-gon, any polygon, is going to be n minus 2 times 180 degrees, where n is the number of sides. So over here, 1, 2, 3, 4, 5, 6, n would be 6, so you'd plug that in, and that would be the sum. So this is the sum of all the angles. It is not one angle, it is the sum of all those angles. Now the corollary says that the interior angles of a quadrilateral are 360 degrees. And if you think about that, of course that makes sense, because a quadrilateral has 4 sides. And since our quadrilateral has 4 sides, n minus 2 would be 2, and 2 times 180 is 360. So let's look at this first couple examples. We want to find the sum of the measures of the interior angles of our hexagon and our octagon. So our hexagon has 1, 2, 3, 4, 5, 6 sides. So n equals 6. So I can say 6 minus 2 times 180 degrees. And 6 minus 2 is 4. And 4 times 180 is 720. So the sum of the interior angles of a hexagon is 720. All right, our octagon, hopefully you know an octagon has 8 sides. So n equals 8. So 8 minus 2 times 180 equals 6 times 180, which is 1080 degrees. All right, now what if we wanted to figure out the sides of the polygon? We know that our sum, in this example 3, we know that our sum is 2,700 degrees. So I can solve for n, because remember n is the number of sides. So I can say n minus 2 times 180 equals 2,700. And so if I multiply both sides by, divide both sides by 180, 2,700 divided by 180 gives me 15. And now I need to add 2 to both sides, so n equals 17. So that would be a 17-gon. All right, and in this one, my sum is 1440, so we're going to set it up the same way. So n minus 2 times 180 equals 1440 degrees. So n minus 2 is equal to 8. Add 2 to both sides. N equals 10. We actually have a name for that polygon. That is a decagon. Decagon. All right. Now, what if we were looking for x? So we want to find the value of x. Well, this is a 1, 2, 3, 4-sided figure, which means it's a quadrilateral. So that means if I add all of my angles together, they should equal 360. Now, you should know that because of the corollary at the top of the page about quadrilaterals. But if you didn't remember that, you could just do n minus 2 times 180. And we had 4 sides, so that would be 360. And so now I have 3x equals 90. And when I divide both sides by 3, I get that x equals 30. Next. Okay, so those were for our interior angles. For our exterior angles, just know that the sum of the measures of all of your exterior angles of a convex polygon is going to always be 360. It doesn't matter what size, what shape it is, it's always 360. And notice these are our exterior angles that come off of our vertices. So you should have the same number of exterior angles as interior. So I have a pentagon here, so I have 5 exterior, I should have 5 interior. So if I add all of these together, x plus 65 plus 63 plus 92 plus 112, they are going to equal 360 degrees. So x should equal 28. So 28 degrees for that little angle right here. All right, take a look at the practice problems. Let me know what kind of questions that you have. All right, so for number 1, you should have gotten 1800 degrees. For number 2, sorry, I didn't notice this typo. This 8 should not be there, and it should be 540 degrees. So sorry about that. Let's see. So if that messed you up, I'm not surprised if it did. So 540 degrees. So that would be a pentagon. Over here on number 3, x equals 71. And on 4, the 7th vertex, your exterior angle would be 43. We really didn't discuss how to do number 5, but so I'm going to go through this one with you. If you have a regular 90gon, that means that n equals 90. So I can find the sum of the interior angles. So the sum of my interior angles is going to be n minus 2, so that's 88, times 180, and that's going to give me 15,840. So that's when I add them all together. But remember, this is a regular 90gon. So that means all my angles are the same. So if I divide by n, that will give me the measure of one angle. So that is going to be 176 degrees. It is still less than 180. Okay? So that is your one angle of a regular n-gon. So if you want to see this equation, n minus 2 times 180 all over n. But remember, this is only for regular. You can't use it for anything but regular polygons. All right, now if I know that my interior angle is 176, then my exterior angle, they're also all the same. So you could find that one of two ways. Your interior and exterior angles form a linear pair. So by that reason, I know that it is 4 degrees. Or you know that all of the exterior angles sum to 360. And it's regular, so I can divide it by n. Same thing though, you can only use these equations if it's a regular polygon. And 360 divided by 90 also gives you 4.